Our next four sections-ish are going to deal with conic sections. So first of all, let's talk about what a conic section is. So here, the blue that you see right here is a cone. So we can cut a cone in different ways. If I cut it straight across like this, I make a circle. If I cut it on a slant, I make an ellipse, which is like an elongated circle. If I cut it like this so that it's cutting down infinitely, I make a parabola. It never closes off at the end. And if I cut it similar to the parabola, but so that it intersects both sides of the cone, that shape, those two branches, are called a hyperbola. So over the next few sections, we're going to talk about each of these figures individually, but we're starting now with circles. So first of all, a circle is all points in the plane that are equidistant from a fixed point called the center of the circle. So I have my center here, and then imagine like I put a piece of a rubber band here at the center, and I stretched the rubber band to a certain point, and then moved all around the center. That perfect thing would form a circle. So that distance here is the radius r, and the center we're going to denote with hk for the x and the y coordinate of where we're plotting it. So then I can just move out that distance r from that center hk. So in our general form for the equation of the circle, in the center radius form, we would write it as x minus the x coordinate of the center, and that whole quantity squared, plus y minus the y coordinate of the center, the whole quantity squared, equals the radius squared. So if I'm centered at the origin, at the point 0, 0, I'd have x minus 0 squared, which is just x squared, plus y minus 0 squared, y squared, equals the radius squared. So this is the form of the equation with the center at the origin. This is the form of the equation with the center anywhere else in the plane. Okay, so I want to find the center radius form of the equation of a circle with radius 6 and center negative 3, 4. So we're going to fit it right into that form. Our h, the x coordinate, is a negative 3, the k, the y coordinate, is a 4, and the r, the radius, is a 6. So putting that into our form for a circle, I'd have x minus negative 3 squared plus y minus 4 squared equals 6 squared. Or x plus 3 squared plus y minus 4 squared equals 36. So that's our equation. If we look at that, our center is at a positive 3, or negative 3, negative 3, positive 4. So we go backwards 3, up 4, that forms the center of our circle. Our radius was 6, so from this point I can count up 6 here, right 6 here, down 6 here, left 6 here, and then draw a perfect circle through those 4 points, and that forms the graph. Notice that the graph is in black. The center is not actually part of the graph. So now I want to find the equation of the circle with the center at the origin and a radius of 3. Well, if the center is at the origin, then we know we're using x squared plus y squared equals r squared. Since the r is 3, plugging in the 3 here, 3 squared gives me a 9. So my equation is x squared plus y squared equals 9. Here, my center is at the origin. My radius is 3. So I go up 3, right 3, left 3, or down 3, left 3, and then draw a perfect circle through those 4 points. And that is my circle that fits this equation. Now, notice that the domain and range here are negative 3 to positive 3, negative 3 to positive 3.